And we're live.
We are live.
Hey, everybody. Welcome back. Monday night, 8 o'clock Eastern time. It's August 31st, and it's already dark outside. It's kind of sad, but hey. Yeah.
Right for me still. I'm in Kansas, so.
Yeah, it's the start of a new school year, a crazy year for many of us, a year that no one imagined ever would come to something like this, and it's almost like we're still in a dream and looking to wake up from it. But we're here to help you out, just to try to working with teaching math remotely with GeoGebra. And tonight we're going to take a half hour to explore an app called Graspable Math. It's a very simple app very simple app to use, and it's an app that needs to belong in every math teacher's toolkit, toolbox, whatever. And I guess the best way I could describe it is it's an awesome app to support students' procedural fluency through a conceptual lens, if that makes sense. So let me just get this icon out of here, and we will go ahead and rock and roll. Remove that. And so, Alice, why don't you go ahead and screen share? And we'll go to, I'll type in the URL, it's graspablemath.com.
Okay. Wait, that's your screen. This one's my screen.
There you go. Yeah.
Wait. How do I tell which screen?
Just the entire one, I think.
Okay, wait. Share screen. No, because I had showed you before.
Got it. There we go. The pink.
There we go. All right.
So graspablemath.com. Yep. So let's go to explore algebra for now. Okay. Ronaldo, we'll work on inequalities most likely next time. Graspable Math, we're going to probably do in a 2 or 3 part series. Okay, for these half hours here. It's an awesome app. Just hit X out of there, Alice. We don't need to see all those preview things. So this is a blank canvas. Remember last time we were in GeoGebra Notes, and Graspable Math was a small part of GeoGebra Notes. You can embed it in. But if you want to use Graspable Math's features, the power, you want to live in this canvas platform right here. You can log in right now in the upper right corner. Why don't you go ahead and log in with Google? Just log in using your Google account you have there.
Log in, okay.
Yeah, so you can save stuff.
Yep. Okay, I'm in. That was
all right. You are in, of course, anytime. So if you go over, if you go over to insert, upper left corner.
Yep.
Okay. If you go over there, you can type in a couple different things: a math expression, a function, text, everything. You can put YouTube in there, and there's GeoGebra apps you can embed in there as well. Okay, perfect. Right there you go.
Or is it just the graphing calculator?
It's the graphing calculator. Really, the calculator suite app, the more powerful one. But let's see here. See how it goes in there nicely. Now I'll tell you what. If you hit arrange, you see arrange in the upper left, in the upper row there, the crosshairs. To the left more. Arrange lets you, now you can adjust the size, move stuff around, right? And why don't you go ahead and arrange that? Why don't you can make it bigger, smaller, whatever, right? You can do a lot of cool things here. And so another feature, another thing I want to show you here is if you go back to you have to go back to transform, which is the recycle looking thing. If you go in the white, okay, go down a little bit in the white, just press and hold down the mouse there, hold it.
Oh.
Now you can, keep it hold down. Okay, you can choose between text, a function like math expression, or a graph. That's kind of a shortcut way to get stuff in there.
Yeah.
All right.
Not my mouse.
Right. So you have the mouse right there. Okay. So you got it right there. So again, that's just a shortcut. So let's actually go to insert or go to FX. All right. We'll put an expression there. Why don't you type in, for the heck of it, 3x plus 4 equals 5x minus 1. I don't know, just making it up there. Okay, done. Yeah. Now, if you want to go to arrange, go arrange up there so you can drag it up. You want to move that whole equation up to give some room there. Yeah, drag that thing up. And so a lot of students, we talk about students, so teachers complain they can't solve an equation. And the teachers are walking around the room thinking like, well, they're all pointing out their mistakes. And I'm like, well, what's your role in the classroom here? With an app like Graspable Math, you can have your students formatively assess themselves so they find their mistakes. Okay, so let's hit transform again. Okay, in the upper, yep. So if you click on the equals, you can transpose both sides. Okay, I think if you double click on it, you can like switch them around. Yep. Okay. And so now we start talking about things. Let's actually take the plus 4. Take the plus 4 and drag it over to the other side, just for ha-has right there, right? Let it go. Okay, and now sort of thinking, I try to tell students, well, let's isolate the unknown. So what else do we have to do? We have to take over the 5x, right? But when you take over the 5x, you have to hold down the shift key. Hold down the shift and click on the x and the 5. Yeah, because you just divided by x, actually. Yeah. So let's undo there. So hold down shift.
I was like, what's...
Yeah, you want to make sure they both turn blue and then
shift.
drag it. Yeah.
All right.
Yeah, there you go.
Okay.
See what I mean? And now let's click on the plus sign between the negative 5x and 3x. So gosh, what does that give me? Yeah, it'll transform it. And then let's do the same on the right. What's negative 1 minus 4? I mean, yeah, students should be able to do this by hand. And now the negative 2 is what's getting in the way, right? So how do we undo multiplying? Oh, right, dividing, right? And so let's actually click on that division symbol right there just to see. All right, now on the dot, click the dot and drag down. Drag all the way down. There's your step by step what you did in that canvas right there. So now you as a teacher can often say the kids did. Let's look at each other's work. You can actually have kids submit screenshots, you project them to the class perhaps, and let's analyze each other's method of solution here and say, well, gosh, you find someone who did different than you. Why is their way say legit? Kind of like that. But yeah, I think the expression there. But again, this is something kind of these are canvases you can set up. I'm actually going to put in the link here for people. I actually pre-made a couple things here just to save us time. Because again, putting in equations, expressions, and Graspable is pretty easy. Okay, but I have a 2-slide Google Slides thing I'm going to put in the comments here, and Alice, I'll throw it in the chat for you as well. Okay, there it is. Let me put it in the private chat so you can get it. There it is. There's just a couple hyperlinks there.
Well, they're not. You have to put. Oh, you put it in the private chat.
I did, yes, so you can get it. Okay. And I put it on the social media feeds as well. Yes. So right here, so there it is. You're more than welcome to come join there. But let's just go to the second slide there. And I just want to show a few examples. Okay, some discovery learning. You can use this for discovery learning, more formative assessment. But if you click on the first link there, okay, you can go to just go there. So this is something that's pre-made. I use with teachers, and all the directions are pretty simple. It says use the transform tool to transform each of the expressions below. So basically, clicking on operations. Students take a few minutes. They click on the operations. I mean, we know what to do, but just go ahead and click on each one, right? You see what you can do. I mean, click on something that you can't do first. We know to multiply first, right? But see here, it's shaking its head. You know what I mean? Got to go, no. 12, 6, and okay, well, you actually got to do the circle to the right of it there. Yep, and then you got all that. Let's see here. Students can quickly just transform it, and as they engage, they're thinking, wow, it doesn't like adding, does it? No, And so basically, right here, where is it? And so basically right here, it's kind of looking at it. You're looking at it as a student and think, okay, well, let's see. Weird. So now the students look at their work, they look at each other, talk to the person next to you, talk to each other. What's going on here? If you look at that writing prompt down there, describe the order we take. Which comes first? What do you notice? And again, instead of us, the teacher, telling them, hey, kids, multiplying comes before adding, let the kids be the ones to tell us.
Exactly.
And so this is a small scale example of something you could do. Now I can build another. Now Alice can actually save that, undo it all. You could save it to her things there. So if you hit undo a bunch of times, or actually if you go ahead and refresh, just refresh the URL up there. All right. If you want to ever use that in like a pre-algebra class on day 1, I don't know, not day 1. I wouldn't do day 1, but like if you go to save in the upper right corner.
Oh yeah, save. You
could save it and then save it to your stuff to your particular profile. It's for the taking.
Got it.
Okay. Yeah.
Okay, cool.
Yeah. Drop the link in Google Classroom, do whatever you can do, stuff like that. Now, let's actually check out the second link there. Again, just a couple of examples here just to see. Graspable Math is a small app, but it's a powerful app. Let's go to Order of Operations 2, just for the heck of it. All right, X out of that thing. It's asking us to use the trick. Now, this is way more complicated, right? Much more complicated. It's the same expression cloned twice. But now students start clicking away. But in the second expression, students are asked now to evaluate this thing a different order. And so we're going to look at everybody's orders now. Let's make some general consensus rules. What can we see? What do you notice? What do you wonder?
Okay, so
So yeah. Right? And so the order of operations, obviously it knows. It's been algorithmically programmed in there, of course. But right here, you can actually start looking.
Operations as much as, I think there's a lot of misconceptions that you have to go left to right. And it's really just an understanding of how things mix together. Like I went over here and, I do the exponents first instead of the parentheses first.
Right.
And here I mean, the square root essentially acts as a parenthesis in itself, but
grouping symbol, yeah.
Individual groups as opposed to in order you have to do it in.
Right. And so again, it's just students could take a bunch of different journeys just to evaluate this expression. But hey, each journey is legit, each is valid, which is really the antithesis of this whole PEMDAS. You do it as I do, I do, we do. Throw that crap out the window, And we could really have kids explore and say, you know what, do we really have to do what's in parentheses first? I mean, like, okay, in certain conditions, I mean, the parentheses are there for a reason. I always like to say parentheses were there just whenever you want to violate the order. You want to do something.
Does it let me do the distributive property?
It does. We're going to look at an example of that in just a second. Yeah, actually, click on the negative. Well, you got to do the 3 minus 1. So the squared's going to not let you do that, of course.
Exactly.
But tell you what, go into click on go to insert for a second. I'll show you right here, right now. Go to insert, expression.
Yeah.
And just type in 2 open parentheses, or open parentheses, say x plus 2y.
Oh, I have an x.
Or that'll work. No, it doesn't have to be an x, but you can keep it like that. Hit done. Okay. Now click on, yep.
There we go.
There you go.
Oh, there we go. Look at that.
Yep. So what's going on there, And again, yes, can photomath do the same thing? Sure it can. But again, there's something transformative about the dynamics here that I really like. Because photomath, to me, it just gives you static images coming after the. I love the action of transformation here, the actual procedural transformation that helps the student make some connections here, that I like. So that kind of thing. And so, yeah, again, now we'll talk about adding and subtracting. We could make another palette with pluses and minuses. And okay, do we really have to go left to right? Which comes first? You know what I mean? So they could see, make their own they can generalize themselves. But Graspable Math's easy to use, and you can make a canvas, save it. Now the text I got there, you just click by going to where it says up there text. I think there's an insert. Insert. Yeah, you just did it before, right? You can make smaller, larger, undo, redo. So eraser, you can show off the erase tool if you want. The eraser just simply just acts like an eraser, and there you go. Pretty nice.
What am I erasing? It looks like it is, but it's not.
Oh, maybe it's a bug. I don't know, but usually typically it does. But yeah, all right, I can let them know. But again, Graspable Math is a partner of GeoGebra, and they're an amazing partner. I mean, like you can embed Graspable in GeoGebra Notes, but you can embed GeoGebra in Graspable. They work together, which is it's really nice. Okay.
I mean, like the drawing is really smooth, isn't
it? It's pretty nice. Really, really cool. Yeah, so can you go to the just to show you what else it can do, can you go to the next thing in the Google Slides, please, when you get a chance?
Yep.
Because this kind of gets boring after a while. Let's talk about substitution.
Okay.
All right. Again, I just came up with a basic example, typical ones that you give kids too many, put you to sleep, but they should be able to do 1 or 2. Now, if you click on the -3, I want to show you something here. Over in the far right corner, click on the -3 so it turns blue with your mouse.
Okay. Wait, it won't let me click on the -3.
No. Click on to the right side where it says x equals -3. You see it over there?
Oh, yeah.
Yeah, click on the -3. No, not the dot. Click on the number itself.
Okay,
yep. Just click the negative. Yep. Drag it over. Yep. Drag it now.
So I had
over drag it to x. Let go. Boom. And would you drag the -4 over to where the y is, please?
Okay, so I got to hold down the shift key.
Yeah. Well, actually, yep. There you go. And now it becomes what you did before. So math teachers cringe whenever they give their students an example. Oh, they're going to mess it up with the negatives. But you know what? If you let them, if you give them less to do and let them formatively assess themselves each time with the expectation that they will, formatively assess themselves, make that as part. It's like quality is better than quantity, But like you can do that, and so start clicking away. Obviously, if you click the minus between the two terms, it's not going to let you do it, right? But you can go ahead and just start transform it away and drag it down. You could see what's going on here. Okay. And there you go. And boom. So step by step, we're analyzing here, so students can now formatively assess themselves and see. All right. What else do we have in that Google Slides thing? A couple other things.
Okay.
All right, so I just want to show you a couple things here. So, this one I think you saw back in the when you looked at GeoGebra notes last time, but I just set this up ahead of time just to save time. But there are boxes. You can actually put box filler places in there, and I'll show you how to do that.
And I was just teaching him this yesterday.
Oh yeah. So go to where it says insert up there. I'll show you how to get the box first. Insert math expression. Okay, so the box is located right there. So box X, you know what I mean? That's how you get it. That's how I put them in there, And so plus box or something like that, and you could exactly see now that box is intended to be filled in by a parameter or a variable or whatever. All right.
Okay.
There you go. Okay. Right. So now you go ahead and take the 1, put it where A typically goes, and there you go. You can put it there too. Right, double. Yep, there you go, and boom.
Okay.
So kids can see like, gee, 1x and x are the same thing. I mean, most kids make that connection, not all, but yeah, go ahead and let's put the -3 in the third box there. Or actually, undo there. Yeah.
I want to know would it let me put in the wrong spot, and it did.
Well, yeah, no, it totally will. It totally will. But I mean, this is just like I said, it's a structural placeholder, really, what it is. It's not gonna autocorrect here, but like, yeah, you could throw it in there. And now, would you go to the circle to the far right of that quadratic there, next to the -3, drag it into the GeoGebra graph. Yep, drag it right. Nope, undo.
Sure.
Take it and just drag it right. There you go. Perfect. Now, I'm going to show you what I showed last time. Hit scrub right up above the scrub tool. Yeah. This will let you scrub coefficients. Now, if you go, if you actually scrub the 1, move it up a little bit.
Whoa.
See?
Yep.
It's going up, and then if you scroll down, gee, what happens when I let A go, up? It gets narrower. So, down, what's going on? Students can actually start transforming these parameters here. Gosh, when A is negative, it opens down. See, they're making the discoveries. We, the teacher, should not be telling them.
I totally agree.
Students can tell us.
Conversation with my math partner today is, we're going over integers, and it's like we can't start this by taking notes. First of all, the kids have been doing it for a lot of years.
Right.
If that worked, they'd be good at it. It's like, no,
right.
It's got to be conceptual.
Totally. And you could do also, and of course, you could drag it into the quadratic formula there, and you can evaluate that the same way we did before. Not that students being able to use the quadratic formula when we have all this 21st century tech should be the end all and all for everything, but for the 1 or 2 examples that they have to do, to show that they could demonstrate mastery of solving a quadratic, say. Again, in the United States, I feel like we're really behind with respect to, testing. In Europe, CAS, computer algebra systems, that's on like standardized graphing calculators that are embedded in state in like country exams. A lot of countries in Europe assume that CAS, like, math solvers exist, and therefore the questions are n times harder,
Exactly.
But in America, it's we got it backwards. I mean, yes, they should have number sense, but, simplifying radicals doesn't prove number sense at all. To me, square root of 50 is a lot simpler than 5 root 2. Because you can estimate it better. You can, you know what I mean? But again, that's a whole topic for a different day. But yeah, so again, Graspable Math, you have it, you got it right there. But what I will do, since what else do we have in the Google Slides thing there? What else do we have going on? You can move C there, but if you go back to the Google Slide thing, was that the last one?
Yeah, I think so.
Okay, so there's one more. Let's show one more. Let me get we went through this pretty quickly. Let me just go dig it up for 1 second, and I'll throw it in the chat there for you, and I'll put it in the chat for everybody watching here. Just let me find it quick. It's pre-made there. 1 second, I apologize. All right, I got it. All right, let's actually take this. All right, Alice, let's actually, let's have you type this up here. We got a couple minutes here. Would you go to just refresh everything, and so we'll just get a blank graspable canvas there? All right, let's do that. I'll have you create it from.
Yep. Or do you want to just do canvas?
New canvas, yeah. So let's see. Here you go. Yep.
Look how quick I learned.
Perfect. All right. Let's go to insert 3D calculator now. We're going to work in 3 dimensions here.
Oh, insert
geometry 3D, they call it.
Okay.
And can you hit arrange and like drag it to the upper corner and make it a little bit bigger?
Mm-hmm.
Please. There you go. We'll drag it down so we can make it, yeah, something like that. Perfect.
All right.
Drag it over. Cool. All right. So click. So now go back to insert. And for the equation, I'm going to give you 3 equations to type in here really quickly. All right, math expression.
Okay.
All right, x
Mm-hmm.
plus 2y
Mm-hmm.
minus z
Mm-hmm.
equals 2. Enter. All right, now insert another one there. We're going to insert two more here.
Wait, we're doing math expression.
Expression, yep. All right, so the next one is x minus y plus 2z equals 5.
Right.
Then the final one is 2x plus 2y plus 2z equals 12.
That's 2y what?
Plus 2z equals 12. Now, granted, some kids are like, well, that's just x plus y plus equals 6. Yeah, great. So what I want you to do now is with transform highlighted, would you drag the first equation to the graph, please? Boom. And I stop right there. I was like, kids, what do you see? What does that turquoisey thing look like? It's a flat sheet. It's actually a plane, right? And all of those ordered periods, like we're in space now. We live in a 3D world, but yet in so much of our math lives in high school and middle school, we live in a 2-dimensional flat chordate plane when life is really 3D, right? So now, can you drag the second one in there, please? Really quickly?
I can.
Yeah. So again, I've worked with teachers. They give these kids 3x3s to solve after system after system. And I ask myself, why? You know, it's like, sure, a 2x2 is more, but 3x3, man, with this. So now, if you go to the circle triangle, the tools in the GeoGebra 3D calculator there, yep, right there. Which tool do you think would be of good use to us here, you think?
Well, they're intersecting at a line.
Yeah, no, don't hit more. Don't hit more. That's all we need right there. But it's in the first menu there.
Intersect.
You said yeah. Touch. How do you think that tool is used?
I do. Okay. Oh, there we go. There's the intersection.
Touch. There you go. So now hit the arrow there, the blue arrow there.
Oh.
Move. That's fine. Now you could spin that thing around. Spin the 3D graphics around there, if you will. So obviously there's infinitely many solutions to that first two because we're talking about an infinite set of points on that line right there, right? Mm-hmm. But now, could you drag the third equation in there, please?
Yes.
Or just, yep, there you go. Boom. Now, here's what I'm going to ask you to do. Would you actually shut off, turn the bubble off on the, okay, you got it. So let's intersect 2 surfaces now. We just got to make sure we take that third plane in one of the other 2, right?
Yep. Okay.
There you go. So now you turn it. So now, can you actually go back to the algebra view in the 3D calculator for a second? And just turn off all 3 planes. Just uncheck the bubbles there.
Wait, those are the lines.
Yeah, keep the lines. You want the lines, right? And again, geometry, great view. 2 planes intersect, they cross the line, right? So there you go. Now spin that thing around there, right? See, gosh, those 2. So I ask students, what do you think the most important part of this whole diagram is? You know, it's like, oh, probably where they cross, right? So if you go back to the tools there, in the 3D calculator there, then there should be an intersect tool, not the surfaces one, but just go down a little bit. It's under points, intersect right there, and just click there. Now, how can I see the coordinates though? Because I just don't see it there. Where would they be? Try the algebra view, the calculator part, with the calculator next to the tools there. See 1, 2, 3, very bottom.
No. Oh yeah. Okay.
And I'll tell you what, if you actually, yep, you got it. Click out, yeah, exit out of that keypad there.
Okay.
If you click on, if you see how that A is gray right there, click on the gray part of that line, like to the left of A. Yep, no, yeah, keep it showing though. But I want you to drag out into the canvas from that. Yep, drag out to, yeah. No, not into the graph. Take A and go to the left. Take that gray area that's shaded and highlight it. There you go. Move it over. Perfect. Oh, it wants to stay there. That's fine. But now, perfect. Now let's just do one more thing. Scrub one more time. Hit the scrub tool. And go back to the calculator. Turn everything on. Put all those planes back in action there. And watch the magic happen with the scrubbing. Now, see that 2y in the top equation? Let's scrub the 2 and see what happens. Scrub the 2 up top there, right? You can see now how the intersection changes as you go through. So in terms of an analysis of like some kind of an optimization problem that typical algebra text would give students, often, unfortunately, artificial ones. But here, you know, we have a means of, you know, effectively analyzing. Instead of working with it algebraically, we're working with it now geometrically, using geometry to solve, say, something that, you know, something like this, to work with it.
Mm-hmm.
So, yeah. But
cool. Wait, where is I lost it? There it is.
Where'd you go? There you go. But again, that's an example of a different atypical way of solving a 3x3, but I think it's pretty powerful in terms of showing things like that. So, yeah. Yeah, I know. We're all tired here. It's Monday, and it feels like Thursday.
I was taking a nap before even. I'm like, I shouldn't take a nap at 6 o'clock, but
it's hard not to.
Monday.
I know. So we will be back. I know I just got text from Chris and Victoria. They said they got caught up in meetings and couldn't make it. But ladies and gentlemen, we will be back here on Thursday afternoon, 2 o'clock Eastern. We're going to try to do 1 or 2 of these a week. I know everybody's busy. It's hard, but try to do for a half hour in a week, just one little tidbit you could take, put in your toolbox, and to help you as you teach math, whether in person, remotely, or hybrid, whatever. So, yeah. Thanks for checking in.
Thanks. Bye.
Bye.